These are going to be the notes for section 2.4, deductive reasoning. The objectives are I will be able to use the law of detachment and I will be able to use the law of syllogism. First off, we need to define what deductive reasoning is. This is just using logical reasoning given statements or facts to reach conclusions. So the two types of deductive reasoning that we'll talk about in this class are the laws of detachment and the law of syllogism. So the law of detachment is a form of deductive reasoning that is used to draw conclusions from true statements. If the conditional is true and the hypothesis is true, then the conclusion is true. So I think the law of detachment is sometimes so easy that it confuses people. There's also a way that people confuse detachment, so hopefully these examples that we do will provide some light on how to do it correctly. So if we have a true conditional statement, remember we talked about counterexamples? So if we have a true conditional statement and we have whatever the hypothesis is true, that means Q is true. So let's take a look at an example. Is number one a valid way to use the law of detachment? So if a ray is an angle bisector, then it divides the angle into two congruent angles. So we need to remember what an angle bisector is. So if I would have angle ABC, and if I said ray BD was an angle bisector, that would break it up. It would divide it into two congruent angles. So we have a true conditional. So here's what we're given. Ray BD bisects angle ABC. Is that the same thing as the hypothesis right here? So ray is an angle bisector. Well, ray BD is an angle bisector because it says it bisects angle ABC. So whenever I draw that, I have this picture right here on the left. So can I make a conclusion that angle ABD is congruent to angle CBD? This is true. So if I look at the picture, it just says everything that is in that scenario. For number two, we say if two angles are vertical, so two angles are vertical, this is our hypothesis, then they are congruent. Well, here's what we're given. Angle 1 is congruent to angle 2. This was our conclusion, which we called Q. So we can't draw any conclusion from this. The reason why we can't draw any conclusion from this is because we have Q. In the prior example, we had P was true. So whenever we have P, that's what we want. We want the hypothesis to be our given information. If you take a look back at what the law of detachment says, it says P is true. So our first example, P was true. Our second example, Q was true. So there's no conclusion. So let's take a look at number 3. It says, if you are a sophomore at Salem. So this is our hypothesis. Then you take driver's ed. Well, it says Hank takes driver's ed. Is that the hypothesis? No, again, it's the conclusion. So we have no conclusion. This is the thing that confuses people all the time with the law of detachment. You need to have the hypothesis given to you. So let's see if number 4 is a case where we can use the law of detachment or not. So there should be an angle symbol there. It's drawn in on your notes. It says if the measure of angle ABC is less than 90 degrees. So what do we think? Is ABC less than 90? Yeah, 42 is less than 90. Therefore, we can write a statement. We can write the measure of angle ABC is acute. I suspect some of you might have questions on this, but again, we have to make sure that what we are given is a scenario where our hypothesis is true. In examples 1 and 4, we have examples where the hypothesis is true in our given information. In 2 and 3, they're not true. We have the conclusion true, and that's why there's no conclusion can be drawn. The second thing, the other type we're going to talk about, is the law of syllogism, which I think is a little bit easier. So with the law of syllogism, I always tell my students to cut the middleman. So it's similar to the transitive property. You might remember the transitive property said A is equal to B, B is equal to C, therefore A is equal to C. You just cut the middleman. So we cut out the B's and we see that A is equal to C. That's the same type of thing we're doing in the transitive property. So what we do is it says if P then Q and Q then R are true conditionals, then P then R is true. So in order to give you a better idea of this, let me just draw something out. I always like to use sports as an example for this. So let's take LeBron James. If you take LeBron James, you know that he's now on the Cleveland Cavaliers. He plays for the Cleveland Cavaliers, and the Cleveland Cavaliers are one of the teams in the NBA. So if I would write this out, I would say, if you are LeBron James, then you play for the Cavs. So we have P and Q. Our second statement would be, if you play for the Cavs, then you play in the NBA. So whenever I say we cut the middleman, we have you play for the Cavs and you play for the Cavs. So I can sort of cut this out. In our example, whenever we use our letters, we would call what I underlined in blue the letter Q. So we call the first circle P, the second circle Q, the last circle R. Whenever we cut the middleman, you get, if you are LeBron James, then you play in the NBA. That's a very good way that we can use logic to come up with a statement and to give you an example. So let's see if these things are true, the same LeBron James example. Vertical angles are congruent. Again, we did this at the beginning where we broke this into an if-then statement. So we would say if angles are vertical, then they are congruent. And the second thing we're given is if two angles are congruent, then their measures are equal. So again, we have the same thing. This is our common thing. So if we cut it, what are we left with? If two angles are vertical, then their measures are equal. So this is a valid conclusion. So we have to cut the middleman. An example like number 6 shows that we're not cutting the middleman. It says if a figure is a rhombus, then it is a quadrilateral. If we want to cut the middleman, what I underline in green here has to say it is a quadrilateral or a figure is a quadrilateral. It says if a figure is a square. So right away, we know that no conclusion can be made using the law of syllogism because we can't cut the middleman. They're not the same. I want you to try 7 and 8 on your own. All you need to do is write an if-then statement, and if there's no conclusion, you would write no conclusion for 7 and 8. I hope this was helpful. Please come to class prepared with any questions you might have, and have a great day.